There's the rod bearings. Here's the rings. After 955,000 miles. This is the rag I used to wipe them off. I wiped off everything. There's no real buildup or anything on this rag. I'm just kind of wiping this down. Little bit, where you can see where that coolant kind of took its toll over a long period of time. But right below that, nothing, man. Just clean. Just perfectly clean. No play. No play at all. We'll check that with a dial indicator.
These are some of the Detroit rings, but just give you an idea.
All right. Let's see.
See how thick it is right in here?
Yeah.
Look how thin it is right in there. See how it wears its ring out?
Oh, where's it thin?
Mm-hmm. That's a compression ring.
And then this is the compression ring?
This one right here.
This one?
See how thick it is?
Wow. Alright. Now, I'm going to take this little razor knife and a vacuum cleaner, little shop vac, and I'm going to scrape all this old gasket material and rust and all kinds of nastiness off of this thing before we continue, because we have to check our liner height on all of our liners to make sure our liner height is consistent next. So I guess I'll get started on that. I cleaned off this deck, the top of the cylinder block, or the engine block, where the liners are, and we have ourselves here a sled gauge, they call it, where you can slide it around and you can check the height of things. Like we can check the step right here on each of the liners. We can see how high the liner is compared to the top of the engine block. It's very important to check this. The proper way to check this, you need to actually compress each one of these liners with a compression tool or an installation tool. And the book says you're supposed to compress the liner, and the set screw for the compression tool you're supposed to torque to 50 foot-pounds. And then once you put 50 foot-pounds of torque on the set screw, pushing down on the liner, then you can check. I don't know if you can see that in the camera. Not this height, not the top edge, but this step right here. This tiny little. Let me grab the sled gauge. This tiny little step right here between these two surfaces. And the rule of thumb is, and I think the book says this. Should refer to the book, obviously. The rule of thumb is the minimum between these two surfaces should be 7/1000ths of an inch. The liner should be 7/1000ths of an inch higher than the top of the block, minimum. And that's pretty low, actually, for an ISX. Most of them came from the factory. It's my understanding that most of them came from the factory at about 0.009, which is 9/1000ths of an inch, or 10/1000ths of an inch. I think the rule of thumb is 7/1000ths to 11/1000ths. Well, I know some performance shops that I've helped with doing some of these engines. They would rather see them up around 11 or 12. They say you can get away with up to about 14 or 15 easily if you're going to do a performance. You're going to build the engine for performance. Like say you're going to put 1,000 horsepower in the engine or something really crazy. Then you need to have this up there around 12 or 14 thousandths, and then obviously you need to hand torque all the bolts and make sure everything is perfect, built very, very well. So this is not going to be built for performance. I'm just going to do the best I can putting my own engine together. It's made for making money, not competition, not to brag about. Like I say, I had the horsepower set on this thing to about 575 horsepower, which is great. So I think I've already checked one. It showed 9 thousandths, but we need to use a compression tool to make sure. The other rule of thumb is if you check whatever this is, cylinder number 1. Let's say number 1 shows 9 thousandths of an inch. Then number 2, 3, 4, 5, and 6 should all be 9 thousandths of an inch. Cummins says, 2 thousandths of an inch difference between one cylinder and the next, which means 9 would be plus, plus 1 would be 10, or minus 1 would be 8. I think that's how you do it. Like I say, I don't do a whole lot of these. I'm just going by what I've learned and gathered. But I can tell you this, they should all be the same. I mean, coming out of the factory, everyone I've ever helped somebody do, they're almost always 9 thousandths or 10 thousandths. They're almost always exactly the same height. If you get one, if it was me personally, if I got one that said 9, 9, 9, 9, and then one that was 7, I would automatically assume that liner had dropped. It's called dropping a liner, where the liner vibrates and then it wears the actual engine block, and then it just drops down again, becomes lower. And then you have a problem with it wanting to not, it'll lose coolant, it'll leak, you'll have problems with it, and the engine won't stay together for another 1,000,000 miles. So if you come across one that's lower than the rest, obviously you need to get it repaired. And if you take the time to get it repaired, obviously you're going to want to bring them all up to about 11 for good measure. If you're going to have to counterbore any of them, use a counterbore tool and you counterbore the block, and then you reseat the liner. So that's what I know about it. So let's go ahead and do that and quit babbling. I got my sledge gauge here. Let me go get my liner installation tool, which we can use to put 50 pounds of foot-pounds of pressure on to check the actual liner height. And that tool, I'd like to show it because it was hard for me to find and get. That tool is here. The installation tool itself is part number 3823615 for my truck. It's an ISX 871 3823615. It's kind of funny, the tool itself says 3823616 that came in the box. And of course, it doesn't come with this foot. This foot goes into the liner and it mates up with the liner here. It didn't come with this foot. I had to buy this foot separate. I guess they sell different feet for different engines. This foot is 3823618 for the ISX CM871. And then for some reason mine, it came like this. Both these legs were welded on here like this. I think this one was like this. You use the head bolts, obviously. It doesn't come in any bolts. Mine was welded on here like this. And it was really, really, really close, but I wasn't happy with it. It didn't fit as well as I thought it would. I mean, the bolt would bind as it went in the hole a little bit. For some reason, when I got mine, I don't know if it's because I had the wrong one, or if that's what they sent me, because I ordered the one for my truck, or if they just made a mistake when they welded it and they didn't get it quite perfect. Being it's a tool and not part of the engine. But what I had to do to mine is I had to take a Dremel tool and I had to cut the weld. I cut the weld out and I cut this off so that it could move, and then I notched the end of it so I could actually move it and set the distance correctly for my engine, because it was off just a tiny little bit, and I didn't like it. It was just enough I didn't like it. So what I did was I did that, and then I brought this one to this side, made them exactly the same height, measured it with a set of calipers, so that this one is free floating and this one is fixed. And now I can use this to compress the liner. You put this on top of the liner, and then you drive the bolt down and you compress the liner to 50 foot-pounds. So I thought I would show that and the problems I had with that tool too. So let's get to it. Put this in like so into one of the holes for the head normally goes on. And I'm going to put this bolt in here. Like so. I think it goes like this. Yep, it goes like this. So, I think I'm going to spin this around so that it lines up with the stem there. so it's not in my way when I go to use the sled gauge. That's it. Now that we have it torqued, we can check the liner height. Yep, I got 9.5 thousandths roughly, right at 10. Yep, right at 10 thousandths. Okay, and I'll do the other side, and let's see what we get. Yeah, we'll zero it out over here. And I've got the same thing when you look at it straight on. Yep, same thing when you look at it straight on. And I guess we'll move to cylinder number 2. From the head, I'm using the tool and this big piece here. If you don't wrap the crank throws like I showed earlier in the video, or I had a video earlier where I was making a video of the bottom when we took the rods out. I took a pig mat and I wrapped it around the crank throw, which is the part where the bearing runs. If you don't protect that, and then God forbid you accidentally drop one of these, you know, guess where it's gonna go?
Right in the...
It's gonna put a ding in the crank throw. Okay, it's gonna put a ding in the crank, and that means you've got some serious problems, because now the bearing won't last very long for that, wherever you put that ding. And you know, you can try to emery cloth it out or polish it out, or you know, it's just not gonna be good.
No.
So, you know, that's why I'm being really careful here. I mean, I don't want to drop them, but I did put pig mats down in here, and I've got pig mats down the bottom of cylinders, just in case. I mean, that's just, you just don't leave that thing exposed.
Right.
So, it's just bad practice. Exactly the same height as the others. Cylinder number 3. Okay, so I've checked the height of the liners on all 6 cylinders in a couple 3 places each. Okay, and they're all 0.010, which is 10,000 of an inch from the edge of the liner to the edge of the block. So they're all exactly the same height on this truck. We're done checking the liner height. The next thing we should probably do is pull the liners out and have fun with that.